Hyundai's smart car manufacturing does not begin with cars. It begins with data. Long before a single panel is stamped or a robot moves, Hyundai's smart factories simulate production digitally. Entire assembly lines exist as virtual twins, tested, optimized, and stress-checked before real machines ever power on. Every movement, delay, and interaction is predicted in advance. When physical production starts, nothing is improvised. Raw materials arrive in precise sequences. Steel, aluminum, and advanced composites are tracked digitally from supplier to station. Autonomous vehicles move components through the factory floor without human direction, guided by AI scheduling systems that adapt in real time. The factory is not reacting, it is anticipating. Stamping lines shape panels with high-speed presses capable of producing thousands of identical parts per hour. Sensors monitor pressure, temperature, and material behavior at every strike. If variation appears, adjustments happen instantly before defects exist. Robotics dominate the body assembly phase. Networked robotic arms weld, align, and bond vehicle structures with micron-level precision. Vision systems verify every joint. Laser-guided fixtures lock geometry into place. Strength is not assumed, it is mathematically enforced. Yet Hyundai's smart factories are not fully autonomous. They are collaborative. Human specialists work alongside collaborative robots,
has arrived.
focusing on inspection,
Hyundai is proud
fine
to
adjustment,
launch the new
and
smart car
exception
series
handling.
across the globe.
Automation provides speed and repeatability. Humans provide judgment and context. The system is designed to amplify both. As vehicle bodies move forward, each one carries a digital identity. The factory knows its configuration, drivetrain, software profile, destination market, and compliance requirements. Robots change tools automatically. Parts arrive exactly when needed. No inventory accumulates. Nothing waits. This is manufacturing as choreography. The paint shop represents one of the most advanced environments in the facility. Air purity is tightly controlled. Temperature and humidity never fluctuate. Electrostatic paint systems coat bodies evenly while minimizing waste. AI vision systems inspect finishes immediately, detecting microscopic flaws invisible to the human eye. Quality is not inspected at the end. It is protected at every step. Once painted, vehicles enter final assembly. Wiring harnesses, sensors, control units, and smart systems are installed. Hyundai's smart cars are deeply digital platforms. Thousands of signals flow through each vehicle. Every connection is tested the moment it is made. Software activates instantly. Infotainment systems boot. Digital dashboards synchronize. Control units communicate. If something behaves unexpectedly, the line corrects it immediately. Errors do not travel forward. Electric and hybrid models add additional layers. Battery packs, power electronics, and cooling systems are installed with extreme care. High-voltage testing verifies isolation and safety. Thermal behavior is measured under load. Smart energy systems are calibrated before the vehicle ever moves. By the end of this phase, vehicles appear complete. But appearance is not readiness. Because smart cars must do more than drive. They must sense, decide, adapt, and learn. That responsibility begins next. If you want to continue once a Hyundai smart car reaches the testing phase, the factory's role shifts. It stops building and starts teaching. Every vehicle entering this stage is treated as a learning system. Hardware may be complete, but intelligence must be verified, calibrated, and aligned. At scale, this is one of the most complex challenges in modern manufacturing. Testing begins immediately. Vehicles roll onto dynamic testing platforms that simulate real-world driving without leaving the factory. Steering inputs, braking forces, acceleration profiles, and suspension responses are measured continuously. Data streams in real time, compared against ideal digital models. Smart systems demand smarter validation. Cameras, radar, ultrasonic sensors, and control modules are calibrated in controlled environments. These systems must interpret the world accurately, day or night, city or highway. Calibration happens under repeatable conditions so that behavior remains predictable once the vehicle reaches the road. Software becomes the central focus. Hyundai's smart cars rely on millions of lines of code. Infotainment systems, driver assistance, battery management, and safety features all communicate constantly. The factory flashes software automatically, verifies system synchronization, and simulates user interactions. If a system responds incorrectly, the factory does not guess. It measures, it compares, it corrects. Electric vehicles add another layer of intelligence. Battery packs are tested under load. Charging behavior is simulated. Thermal systems are stressed. Energy efficiency algorithms are evaluated in real time. At this scale, safety and longevity cannot be assumptions. They must be proven repeatedly. Noise, vibration, and comfort are also engineered digitally. Acoustic chambers isolate unwanted frequencies. Cabin materials are adjusted. Seal integrity is verified. Comfort becomes a measurable output, not a subjective afterthought. Environmental testing pushes limits. Climate chambers simulate extreme heat, cold, humidity, and altitude. Water tunnels expose vehicles to heavy rain and pressure. UV systems age materials rapidly. Each test answers one question: will this car behave intelligently anywhere it is driven? Throughout this phase, AI systems monitor patterns. If a recurring deviation appears, the factory adjusts assembly processes immediately. The learning loop is short. Improvement is constant. Before final approval, human evaluators step in. They are not testing speed or performance. They are testing feel, steering weight, pedal response, interface clarity. Human perception still defines success where experience matters. Only after passing mechanical, digital, and experimental validation does the vehicle move forward. But the factory's role is not complete, because intelligence does not end at delivery. If you want to see how Hyundai's smart factories continue learning after cars leave the line, make sure to subscribe to the channel. When a Hyundai smart car leaves the factory, production does not end. It expands. Before shipping, each vehicle is digitally registered. Hardware configurations, software versions, sensor calibrations, and diagnostic states are recorded into Hyundai's global systems. The factory retains a complete memory of what it built. Logistics become part of the intelligence. Vehicles move through automated storage zones and climate-controlled shipping areas. Autonomous logistics systems schedule rail, road, and sea transport dynamically, minimizing handling and exposure. Delivery is treated as precision, not movement. Once vehicles reach drivers, the learning accelerates. Hyundai's smart cars are connected platforms. Over-the-air updates refine software, improve energy efficiency, enhance safety systems, and introduce new features without physical recalls. The vehicle evolves while in use. This evolution is powered by real-world data. Anonymized driving behavior, system performance, battery health, and environmental conditions flow back to Hyundai's data centers. These signals reveal patterns impossible to fully predict in laboratories. The factory listens. AI systems analyze trends across millions of vehicles. Engineers identify improvements. Software updates roll out. Hardware designs evolve. Manufacturing processes adapt. What happens on the road reshapes what happens on the line. Electric and autonomous technologies amplify this feedback loop. Battery degradation patterns inform next-generation energy systems. Sensor performance data refines perception algorithms. Charging behavior influences infrastructure planning. Manufacturing responds accordingly. Sustainability becomes inseparable from intelligence. Hyundai's smart factories integrate renewable energy, water recycling, energy-efficient robotics, and waste reduction strategies. Efficiency improvements scale across global production, multiplying impact. Inside the factories, learning never stops. Artificial intelligence continuously optimizes scheduling, energy use, and material flow. Digital twins simulate changes before implementation. New assembly techniques are tested alongside live production without halting lines. The factory evolves in real time. This adaptability allows Hyundai to produce combustion, hybrid, electric, and future autonomous vehicles on shared platforms. Flexibility is not compromise, it is resilience. The most remarkable achievement is how invisible this complexity feels to drivers. They do not think about sensor calibration when assistance systems respond smoothly. They do not notice energy optimization when range remains stable. They simply trust the car. Smart manufacturing is not about replacing humans. It is about extending intelligence across machines, software, factories, and vehicles. Hyundai's smart factories are no longer just places that build cars. They are systems that learn. Which part of Hyundai's smart manufacturing process impressed you most? AI-driven production, intelligent testing, or continuous learning after
Calibration
delivery?
complete.
Leave a comment and share your thoughts.